Here we go, Math 8. We got lesson 4-6, dilations, day 1. Heard that the Silva family has been watching these videos. So this video, Silva family, if you're listening, this is dedicated to you. Here we go. Dilations. We're going to try to do a transformation. And this time, instead of creating a rigid motion, they're going to create something called a similar shape instead. Okay, so they're going to have something called a scale factor. That either enlarges, makes it bigger, or reduces our shape. So instead of keeping a congruent shape, dilations do not create congruent shapes. They make shapes that are bigger or smaller, but they're going to be similar to each other. Okay, the scale factor is based on the distance to the point of the dilation. Dilations are not rigid motions. That means they are not congruent. Since they're not congruent, let's see what they are. They are what we call similar instead. Similar shapes are not congruent. They have congruent angles, so the angles will all be the same measurement. But the sides are going to be proportional, which means like if we're multiplying by 2, if one side is 5, the other side will be 10. So they're going to be some kind of multiple of each other when we do the sides. So angles, congruent. Sides, proportional. So that means they're going to be similar instead. And we'll show you what that means in a second. The scale factor is the multiplier, so the number that we're multiplying, that compares the image to the pre-image. So our scale factor, SF, this can be found by finding the distance from the image and then dividing it by the distance of the pre-image. Okay, so if I have a scale factor bigger than 1, like, I don't know, 3, that's bigger than 1, that will make an enlargement. So a scale factor of 3 means we are tripling our size. So we call those an enlargement. If we have a scale factor smaller than 1, like, I don't know, 1/2, that is going to be a reduction. And all it simply means is we're going to be half the size. All right, so here's what I've got. I've got a diagram right here. This is a dilation. This is my pre-image right here. Oops, pen's running out of ink. That's my pre-image. And this is my image. So original, copy. This is the point of dilation. So a dilation kind of works like, I don't know, like a screen projector, right? So when you project something from your screen, light travels in a straight line. So this is the projector. Light's coming out of the projector, and the farther away you are from the projector, the bigger the image is. So here we're far away from the projector, here we're close to the projector. So anytime you're doing a dilation, you should be able to draw a line through the point of dilation to the pre-image to the image. There should be a straight line there. So that's one of the things you should do to double check that it's working. Now this particular dilation that I've done here, we can find out how much bigger this shape is. So here I can see on this side right here, this is 1, 2, 3. That's 3 units right there. Now let's measure a corresponding part on the other one, so a matching part. Let's do this one right here. So there's my corresponding part. Let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. Can you see how much bigger it's getting here? The difference from 3 to 9, this is 3 times as big, right? So if we're looking at this, the distance of the image, this distance is 9, divided by the distance of the pre-image. So there's where I can see the distance is tripling. So this says where can you see the distances tripling? So the first thing that I can see is that the sides are tripling. We can see this side here and this side here. If I do my image divided by my pre-image, I can see that I'm getting a scale factor of 3. So the sides are tripling in size. That's what we mean about being proportional. They're not the same, but they're basically the same shape, just this one's bigger. All right, where else can I see that we have distances tripling? The second place that I can see distances tripling is the point of dilation to these other points here. So if I do from the point of dilation, I'll just call that the POD, to the image and pre-image, let's look at this. So this to this point here, we're going 1, 2, 3, 4, 5, 6, 7, 8, 9. And then from here to here, that's 1, 2, 3. So I'm getting that 9 over 3 ratio again. So I'm seeing the scale factor again right there. Where else am I seeing a difference of 3? Just a second, I got the hiccups. I got to stop this. All right, I think my hiccups are on. All right, here we go. Where else? I can see if I take my slopes from the point of dilation to the image and the point of dilation to the pre-image. So the point of dilation slopes, we can also see are tripling. So the slope from the point of dilation to the image, that goes 9, 10, 11, 12, 13, 14, 15. 15, 1, 2, 3, 4, 5, 6. So it goes up 6 and over 15. So this goes up 6 over 15, and that's to the image. The pre-image, if I count out this slope, it goes over 1, 2, 3, 4, 5, and then up 1, 2. So we've got up 2 over 5. So here we can see that we're multiplying the top by 3, and we're multiplying the bottom by 3. So that's another place that we're seeing that tripling happening. So the sides are triple the lengths. The distance from the point of dilation to my pre-image and then my image also is a tripling. And then if I look at the diagonal lines here, the slopes are also tripling. Everything's tripling to get our new shape. All right, so here we go. We are going to dilate triangle ABC at the origin. So this is going to be the point of dilation, B, with a scale factor of 2. Okay, so this is my point of dilation. So this means that B is going to stay in the same space. It's just like if we had this being on the line of reflection, it stayed in the same spot. If when we were rotating, we were right here, that stayed in the same spot. So the same thing for this. If you've got a point on the point of dilation, that point stays the same. So we're going to do a scale factor of 2. So that means this shape is going to be doubled. Okay, so right now this is 1, 2, 3 up to here. So in order to get to the image, I'm going to have to double that distance. So I'm going up 3, I'm going to go up 6. That would be A prime up here. Over here, from the point of dilation to C, that's a distance of 2. I'm going to double that. So that's going to be a distance of 4. So this would be C prime over here. All right, so my new shape is right here. So the original shape is inside of my new shape. You see that? So here's my original shape. It's inside of the bigger shape. Now I can prove that we doubled the size. How can I prove that? Distance from here to C prime is a distance of 4. So for our scale factor, it's the distance to the image. So the distance to the image is 4. The distance to the pre-image, the original, was 2. So this is a scale factor of 2. We can see from the point of dilation here to the image of A prime right up here that that is a distance of 6. And the distance to the pre-image was 3. 6 over 3 is also 2. So we can see here that we are doubling the size. Now, this is a similar shape because these sides are proportional. See how they all reduce to 2 when we compared them? That's what proportional means, is they reduce to the same number. But the angles are not proportional. The angles are congruent. What that means is this angle up here is exactly the same measurement as this angle down there. The angles are the same. So the angles are congruent. It's the side lengths that are not congruent. The side lengths end up being proportional. Their proportion is the scale factor, which is 2. So this angle has the same measurement as this angle, and this angle has the same measurement as that angle. So the angles are congruent, but the sides are proportional. In this case, our proportion of our sides is 2 because we doubled. All right, what if we wanted a scale factor of 3? Now we're going to start at the origin. The problem with this one is I'm not just going left and right. I've got a slope when I go down to these next numbers. So if I want to get a scale factor of 3, that means I'm going to triple the size of my shape. So if I want to go from here to here, I would go down 1, back 1. If I want to triple that distance, I would go down 3, back 3. I multiplied down 1 over 1. I multiplied the down by 3, and I multiplied the over by 3. This should be D prime right here. Now, how do I know for sure that's D, where D prime should end up being? Because I can draw a line from the point of dilation through the pre-image to my new image over here. So there should always make a straight line from the point of dilation to the image to our eventual pre-image. All right, let's look over here. This one goes left 1, up 2. I want to triple this. So instead of going left 1, I'm going to go from the point of dilation, left 3. Instead of it just going up 2, I'm going to triple that. I'm going to go up 2 times 3. I'm going to go up 6. 1, 2, 3, 4, 5, 6. This should be where C prime shows up at. And we can double check to see if we did this correctly by making sure that we can make a straight line from the point of dilation through the pre-image to the image. And we can. So we've made a straight line from the point of dilation to the pre-image to the image. So our new shape is this line over here, and it should have been tripled if we've done this correctly. We can double check to make sure it has been tripled. CD has a distance of 1, 2, 3. So if I'm tripling this, C prime, D prime should have a distance of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, we did it right. You following us, Silvas? All right, here we go. Next one. Compare the coordinates of C and C prime. Then compare the coordinates of D and D prime. Okay, so C was at -1, 2. C prime is at -3, 6. Okay, okay. D to D prime. D was at -1, -1. D prime is at -3, -3. What do you see there? C to C prime, D to D prime. See what happened? Coordinate notation for this, my friends, is 3 times x, 3 times y. Both the x and the y got multiplied by 3 when I tripled, when I had a scale factor of 3. So if I wanted to, this only works when you're going from the origin, but if your center of your dilation is at the origin, and you start with -1, 2, and your scale factor is 3, multiply -1 and get 3, multiply 2 and get 6. Over here, the scale factor is 3, multiply by 3 and get -3, multiply by 3 and get -3. So we can see here that if the scale factor is 3, you're just going to multiply your x coordinates and your y coordinates by 3 to get your new point. That is helpful. All right, that's all I got. Silvus, thanks for watching. I will see you guys later. Bye-bye.